us discuss about elastic potential energy. We know that when we pull a solid rod by a force F, there is an increase in length delta L. But we know that when we are going to pull a rod, a restoring force comes into play. That restoring force brings or tries to bring that rod into its original configuration. The average restoring force that comes into play as the force increases from 0 to F. So the restoring force, the average restoring force that comes into play, that brings or tries to bring it, that is rod, into its original configuration is 0 plus F divided by 2. So that is equal to F divided by 2. So the average restoring force that comes into play, that is equal to F divided by 2. So we have to work against that restoring force, and that work done against that restoring force is stored in the body as its potential energy or as its elastic potential energy. So we have to just find out what is the amount of work done against that restoring force. We know that from the knowledge of work, energy and power, work is equal to force into distance, as the angle between the force and this delta L, which is increase in length, is 0 degrees. So cos theta is equal to 0 degrees. So W is equal to F dot S, that is equal to F into S. That equals to F by 2, that is the restoring force, F by 2 into delta L. So that work done is stored in the body as its elastic potential energy. So we have U is equal to 1 by 2 F delta L. Now, if we divide it by A and delta L divided by L and product it with AL, where A is the area of the cross section and L is the length of the rod. Now we know that force per unit area is stress and delta L by L is strain and AL is volume. So we have that U divided by AL is 1 by 2 stress into strain. Now U divided by AL is potential energy per unit volume, so we show it by small u, that is elastic potential energy stored in the body per unit volume is 1 by 2 stress into strain. Now we are also aware of the Young's modulus being equal to stress by strain, or we can say that stress is Young's modulus into strain. Now we will substitute the value of stress, that is Young's modulus, into strain in this equation. So we have got elastic potential energy per unit volume is equal to 1 by 2 Young's modulus into strain. That is U is 1 by 2 Young's modulus into strain square. This is the potential energy or the elastic potential energy stored in the body when it is acted upon by a deforming force. When it is acted upon by a deforming force, a restoring force comes into play, which tries or brings that body into its original configuration. The work has to be done against that restoring force, and the work done against that restoring force comes in the form of, or remains stored in the form of, elastic potential energy. Hope you understood. Thank you.